does it converge? So you can pretend like you're given a sub n every time, the sum of the a sub n every time. It's your job to find b sub n. And the trick is this. So we'll assume a sub n is equal to 5n minus 3 over n squared minus 2n plus 5. So what's the trick for finding b sub n? Well, I can't say this trick works every time, but oftentimes we construct b sub n by taking the highest power of n, and then if it's a rational function like this, if a sub n is a rational function, we take the highest power of n in the numerator and divide it by the highest power of n in the denominator and construct b sub n that way. That works well, as you'll see. And so we get n over n squared, which is really 1 over n. Now, what are you expecting to happen with the series? What's the sum of 1 over n do? Sum of 1 over n is a p series with p equal to 1, so it must diverge. So we're expecting divergence, but we've got to get the hypotheses of the limit comparison test to work out. We need to find that limit L and make sure that it's finite and bigger than 0 if this is going to work. So we're not by the way, we're not having any trouble here with both of these being greater than 0. That's not going to be an issue. But we do need to find I'll say it this way. We do need to find this ratio and then find the limit of the ratio as n goes to infinity. So check it out. If we take this ratio, we have 5n minus 3 divided by n squared minus 2n plus 5 divided by 1 over n. Would you agree with that? How do you turn that into a multiplication problem? Flip which one? Okay. So we're going to flip this guy and multiply. And then you can see why this trick works. We're going to get the same then degree polynomial in the numerator as we have in the denominator, which is going to allow us to easily take the limit. So what do you get for this guy when you distribute the n here? 5n squared minus 3n over the same denominator, n squared minus 2n plus 5. Yeah, kind of out of room there, so let me go down here. Okay, I'm going to use the arrow notation so I don't have to rewrite a whole limit statement, LIM statement. So I gave you a quick way to decide what this converges to last time. If it's a rational function, the degree of the numerator equals the degree of the denominator, then what's the quick trick for determining the limit? It's the ratio of the leading coefficients. You could prove that using L'Hopital's rule would be a good way to prove it. So, but I'll just take 5 over 1. That's going to be our L, which is certainly finite, and it's certainly greater than 0, right? So we've got a sub n, b sub n, both bigger than 0. We've got that the limit of a sub n divided by b sub n as n goes to infinity equal to 5, which is a finite number bigger than 0. This means that the limit comparison test applies. You know, I won't make you say that, but I will just say at the end, by limit comparison test. So the conclusion is, well, okay, wait a minute. Before I get the conclusion, I need to say something about the sum of the b sub n. Next, the sum from, I think it was n equals 1, right? Yeah. The sum n equals 1 to infinity of 1 over n diverges. What's the reason? It's p series with p equal to 1. Remember, in order for it to converge, p has to be bigger than 1, right? And then finally your conclusion, thus, I can't see it, so I'm just going to say the original series diverges, and what's the reasoning? How do you want to shorten limit comparison test? LCT.